The role of artificial intelligence, AI, in reshaping the landscape of scientific publishing is becoming increasingly prominent, with the potential to revolutionize how scientific knowledge is stored, accessed, and disseminated. Traditional academic publishers have long been the gatekeepers of scientific information, controlling access to peer-reviewed research through subscription-based models and high publication fees. However, AI-driven solutions are emerging as a powerful alternative, offering the possibility of a central, open-access database of scientific knowledge that could replace traditional publishing models. One of the primary advantages of AI in this context is its ability to efficiently organize and curate vast amounts of scientific data. Machine learning algorithms can categorize research papers based on topics, keywords, and citations, making it easier for researchers to find relevant studies without the need for manual indexing. AI can also enhance the peer review process by identifying potential reviewers based on their expertise, streamlining the evaluation of manuscripts, and even detecting issues such as plagiarism, data fabrication, or methodological flaws. Furthermore, AI-driven platforms can provide real-time updates on the latest developments in various fields, ensuring that researchers have access to the most current information without the traditional delays associated with journal publication. These platforms could offer features such as personalized content recommendations, automated summaries, and interactive visualizations, making scientific knowledge. Another critical benefit of AI-based scientific databases is their potential to democratize access to knowledge. Many researchers, especially those in developing countries or smaller institutions, face financial barriers to accessing subscription-based journals. An AI-powered open-access repository could eliminate these barriers, fostering greater inclusivity. Additionally, AI could facilitate interdisciplinary research by identifying connections between seemingly unrelated fields. By analyzing patterns across different domains, AI systems can suggest novel research directions and collaborations that might not have been apparent through traditional publishing methods. This could lead to groundbreaking discoveries and innovations that transcend disciplinary boundaries. And despite these promising advantages, there are challenges to consider in replacing traditional academic publishers with AI-driven solutions. Concerns about data security, intellectual property rights, and the reliability of AI-generated content must be addressed to ensure the credibility and trustworthiness of such platforms. Moreover, the role of human oversight in curating and verifying scientific information remains crucial to maintaining quality and integrity. In conclusion, AI has the potential to disrupt the traditional academic publishing industry by creating a central, open-access database of scientific knowledge. By leveraging AI's capabilities in data organization, peer review, and accessibility, the scientific community can move towards a more efficient, inclusive, and collaborative future. However, careful consideration of ethical, legal, and technical challenges will be essential to realizing this vision successfully. The traditional model of academic publishing, dominated by large publishers such as Elsevier, Springer, and Wiley, has long been criticized for its high costs, restricted access, and slow dissemination of scientific knowledge. With the advent of artificial intelligence, AI, a transformative shift is underway, proposing an alternative approach: an AI-driven central database of scientific knowledge. This vision aims to replace the current fragmented publishing system with an open-access, AI-curated repository that can aggregate, analyze, and categorize vast amounts of research in real time. AI systems can efficiently manage the peer review process, summarize findings, and ensure accessibility to the global scientific community, reducing reliance on costly journal subscriptions. Such a system could democratize knowledge, enhance collaboration, and accelerate scientific progress by removing financial and institutional barriers that limit access to information. Platforms like AirXIV and BioRxiv already provide free access to preprints, hinting at the potential of a fully AI-driven centralized knowledge database that automates curation and quality control. An AI-powered central repository would be like a universal library, constantly updating and organizing scientific literature for instant access by anyone, anywhere. The current academic publishing model operates on a paywalled system that restricts access to valuable research for individuals and institutions that cannot afford costly subscriptions. This model has led to inequalities in knowledge dissemination, disproportionately affecting researchers from developing countries and independent scholars. Additionally, the lengthy peer review process, high rejection rates, and redundant publication cycles hinder the rapid sharing of scientific discoveries. AI-based platforms could eliminate many of these inefficiencies by offering automated content verification, instant peer reviews through natural language processing algorithms, and broader dissemination without institutional restrictions. Furthermore, AI could ensure that research findings are contextualized and categorized based on evolving scientific trends, making it easier for researchers to find relevant information quickly. And you would get, hopefully, the best of the best. A 2019 study found that nearly 70% of published scientific literature is locked behind paywalls, preventing millions of researchers from accessing critical information. Traditional academic publishing is like an exclusive club where only members can enter, whereas AI-driven databases could provide open doors to everyone. AI has the potential to revolutionize scientific knowledge management by acting as an intelligent curator that processes, indexes, and organizes research papers across disciplines. By leveraging machine learning algorithms, AI can automatically analyze research content, extract key findings and cross-section data from various sources to identify trends and gaps in knowledge. Natural language processing, NLP, enables AI to summarize complex studies in layman's terms, making scientific knowledge more accessible to broader audiences, including policymakers and industry professionals. AI's ability to recognize patterns in vast data sets allows for more accurate and comprehensive literature reviews, facilitating more informed decision-making and hypothesis generation for future research. Moreover, AI-powered databases can be continuously updated in real time, ensuring that the latest discoveries are promptly integrated into the scientific corpus. Google's AI-powered tool Semantic Scholar currently employs machine learning to analyze millions of scientific papers and generate insights across multiple fields. AI as a scientific curator is like a highly efficient librarian who reads, organizes, and suggests the most relevant books based on readers' interests. Despite the promising potential of AI to replace traditional publishers, several challenges must be addressed before widespread implementation. One major concern is the accuracy and reliability of AI-generated summaries and categorizations. While AI can efficiently process large volumes of data, it may struggle with nuances, contextual understanding, and the interpretation of complex concepts across different scientific disciplines. Additionally, ethical concerns arise regarding data privacy, intellectual property rights, and the potential biases embedded within AI algorithms. Another significant challenge is convincing the academic community to transition from traditional models to AI-driven repositories, as there is a deep-rooted trust in established journals and their impact metrics, such as the journal impact factor. Effective collaboration between AI developers, academic institutions, and policymakers will be crucial to ensuring a seamless transition to AI-driven scientific publishing. Efforts to implement AI-driven platforms such as OpenAlex have faced challenges related to quality control and adoption resistance from traditional academic institutions. Implementing an AI knowledge repository is like replacing a well-established public transportation system with autonomous vehicles. Promising, but requiring significant adjustment. One of the most critical functions of academic publishers is overseeing the peer review process, ensuring the accuracy and integrity of published research. AI offers the potential to streamline and enhance this process by automating the initial screening of manuscripts, checking for plagiarism, assessing methodological soundness, and even identifying potential biases in research. AI models trained on large data sets of scientific publications can detect inconsistencies and provide suggestions for improvement, reducing the burden on human reviewers. Furthermore, AI-powered quality control mechanisms can analyze citations, assess reproducibility, and flag potential conflicts of interest. thereby improving the overall reliability of scientific literature. AI-driven platforms like Cite Spellcheck use machine learning to analyze citation patterns and evaluate the credibility of reference studies. AI in peer review is like an advanced spell checker, not just correcting grammar, but identifying deeper inconsistencies in argumentation and data interpretation. The integration of AI into scientific publishing raises numerous ethical concerns, particularly in terms of data ownership, transparency, and accountability. Questions arise regarding who owns the data processed by AI, how AI systems are trained, and whether biases in algorithms could influence research visibility. There is also the risk of AI being used to manipulate research findings or to prioritize publications based on algorithmic popularity rather than scientific merit. Ethical AI frameworks must be established to ensure that AI-driven publishing systems operate with fairness, inclusivity, and accountability. Researchers, institutions, and AI developers must work together to develop transparent models that prioritize accuracy and prevent the monopolization of knowledge by a few entities. Recent concerns about AI bias in hiring practices highlight similar risks in research, where AI algorithms may inadvertently prioritize studies from certain regions or institutions. The ethical challenges of AI-driven publishing are like automated credit scoring systems, useful but prone to hidden biases that can unfairly disadvantage certain groups. The current academic publishing industry is a multi-billion-dollar sector, with major publishers generating revenue through subscription fees, processing charges, and licensing agreements. An AI-powered central database could disrupt this economic model by offering free or low-cost access to research, potentially reducing financial barriers for researchers and institutions. However, the shift to AI-driven publishing raises questions about funding and sustainability. Who will finance the development and maintenance of such a large-scale AI system? Furthermore, AI-driven platforms could challenge the financial viability of traditional journals, forcing them to innovate and adopt new business models that prioritize accessibility and affordability. The open access movement, led by initiatives such as Plan S, advocates for free dissemination of publicly funded research, aligning with the goals of AI-driven publishing. The economic impact of AI-driven publishing is similar to how streaming services disrupted traditional television networks, offering more accessible alternatives but challenging existing revenue models. AI has the potential to facilitate new forms of academic collaboration by connecting researchers across disciplines and geographic locations. AI-driven platforms can recommend potential collaborators based on shared research interests, assist in generating research ideas, and even help in drafting collaborative grant proposals. By leveraging natural language processing and big data analytics, AI can identify emerging scientific trends and encourage interdisciplinary collaboration, breaking down silos between different fields of study. This could lead to more holistic and innovative scientific advancements. AI-powered platforms like ResearchGate already use algorithms to suggest collaboration opportunities based on researchers' publication histories. AI in academic collaboration is like a matchmaking service, bringing together like-minded individuals to achieve common goals. AI holds the potential to revolutionize scientific publishing by creating an open, accessible, and efficient central database of knowledge. While challenges remain in implementation, ethical considerations, and adoption, the benefits of democratizing scientific information make AI an invaluable tool for the future of research. Collaborations between AI developers and academia can help refine AI-driven platforms to maximize their benefits. AI in scientific publishing should be seen as an evolving tool, enhancing human capabilities rather than replacing them.